that we have to bridge. So, whatever we have seen in the research part till now, and whatever the industrial lecture was there. So, in industrial lecture, there were innovations. In the research part, there was a lot of good science happening. But what about the gap? And that intelligence we have to figure out. Fine. So, mostly this talk will be around finding those gaps, finding those needs, and understanding those needs, and to start the process of research or maybe the inventing things from the that point of view. Right. So here I think you must be having few sheets of need-based need finding worksheet. One is empathy map and one is uh, problem identification canvas. I hope everybody is on sheet, right? So we will do these exercises. This is the last hour, tough hour. So I thought to make it more engaging with the people. Fine. Okay, good. So whatever understanding we have of about signal processing till now, do you think that that signal processing control system, whatever the intelligent AI like you know about it now, can you use that to solve some problem for this kid? Can you use your knowledge to solve that problem for this kid? Any thoughts? How?
By tracking food department distribution and these data.
Okay. So now the question is, so we are doing this need finding exercise. Okay. We all are good with technology. We all are engineers. We know very good signal processing and all that. But how that signal processing is reaching to this guy? Any idea? Any thoughts? Okay. So what is the problem that we can see here? Problem of malnutrition. Okay. Fine. So the whole point is, does he need smart healthcare? Okay. The intelligent signal processing and control system will create value for him or can create value for him. How? Any guesses?
What are the makings? What are the problems?
Any specific problem that you can figure out?
You can detect.
So the disease that we can see here is a malnourishment as of this picture. So how your knowledge of signal processing or control system or AI can help us to solve this problem? Any thoughts? So this kid is malnourished. He needs good food. Everybody agrees? For that good food, what is the right index or parameter that we should have? Great. BMI index.
BMI.
If we know his BMI index, then we can provide him with a right nutrition. Okay. Can we calculate his BMI just only with this picture? How? Height we can calculate. What about the weight? We are doing so much AI, we are doing chat GPT, everything, but till today, even today we can't calculate his weight using the picture. And that is the problem.
This is not feasible, no?
We have to make it feasible. As an innovator, you can't say this is not feasible. We have to make it feasible. There are, you can think of, you can always think of. But again, there are challenges. And then you have to solve those challenges. As a researcher, as a scientist, you can't say we can't do that. Okay? As long as it is scientifically possible. Right? So we'll come to this. So these kind of problems are called as uh, something different from the tame problems. Okay? So we will come to this kind of problem. So the whole point is we are doing this project with one of the constituency in Chhattisgarh, and here we are trying to get its weight from the image. We are trying different things like getting the volume of this kit, and then again the challenge is the bone density. Okay, if bone density is less, then definitely weight will not be proper. So all this research we are doing. So my point is, we all know good signal processing, everything, but it is still not smart. It is not intelligent enough to solve these problems. And I think when it comes to India, this is one of the most basic problems that we all have to address, or maybe the similar kind of problems. Okay, otherwise not much use of the kind of developing LLM models or doing high-end signal processing and those kind of things. The point is that is good. Research is required. We need invention, but we should choose the right use cases. Okay. EEG, ECG, EMG, everything will be helpful for him only when he will get the proper nutrition. Agree? So this will be the whole flow of the top. So first we will see what is smart healthcare, why it is required and more as of today. Then different approaches to solve human centered innovation approach. So this is a very like innovation pipeline called as design thinking. So we will have just a bit about it because it itself is a one semester course, but I will try my best to give you the idea. Then the need finding, okay, for which we have these exercises. Then problem finding. Then coming on to the tame versus wicked problems. So the problem that we have just seen is the wicked problem. Okay? You can write it down also. Wicked problem is a very important keyword in opposition to the tame problem. So tame problems are some problems which are engineering problems. In the sense, we have a cooked formula, we are giving the input, we are getting the output. Right? Most of the engineering problems are like this. What are tame problems? Tame problems are we are solving a problem and we are creating new problems. That was happening in the last case. Right? But we have to solve that. We can't stop. Okay? Then we have to solve those problems. So the kind of problems which has human intervention, the kind of the problems which has human emotions are mostly wicked problems. Okay. Now the problem that I have told you about that malnourished child, most of means if we can also think of that, okay, we have an Anganwadi worker, they can measure the weight, they can take the height and everything. Okay, everybody will agree. But you should also know that that doesn't work actually. Okay, because of leave, because of their own problems, because of maybe they are not sincere about their jobs. Okay, so the right data is not going to the government who is providing the nutrition. Getting the point? So the only so the best way to get the right things out of it is to make it technology dependent. And that's why we need the weight from the image. There could be many alternatives also, but maybe they will not be that much perfect. Fine. So this was something comes under the tame problem. Then we will see some case studies of intelligence in the processing and control. So coming on to the smart health. So when we talk about smart healthcare, I think mostly the healthcare should work. If we are doing a lot of signal processing, lot of uh, like control systems and all that, and it is not reaching to the end people. We need to think more about it, right? And that is the reason that yesterday a gentleman told, I think he was a senior professor, who told that we don't have a good BP machine also, and this is fact. We don't have a good reliable BP machine even today at our home. In hospitals, it is there. Fine. And moreover, in the remote places like Sikkim, you can't do any good measurements at your home, right? Why? It's like we have such a big population and a lot of engineers. Because we are not doing the right need finding, right? We are doing good research, we are doing good inventions, but those inventions are not converting into innovations. So I talked to that girl who had taken that industrial part. She told about VR and all that. They are mostly importing, right? Why? Because we don't have that mindset of innovation as an engineers. Even PhD scholars. Even if you're a PhD scholar, you should think of a product that should come out of your PhDs, right? Think on those lines. So that is the reason we will do that right need finding and all that. So the healthcare should work. We should convert inventions to innovations, right? We should convert inventions to innovations. Invention part is something that we have seen from Dr. Pichori and all that, right? Innovation we have seen in the industry part. We are at this page. So this talk will help you to bridge this gap, right? That can create effective value for the end user in most usable way. Having the design that can work. In one of the talk, one of the speaker told that they are making CGMs, continuous glucose monitors, but people are not using. Why? Technologically, we are great. We can do 3D printing. We can do all kind of virtual reality. We can do all kind of AI. But the kind of engineering that we are doing there in signal processing and control systems, that is not reaching to the end user. We have made CGM, but it is costly. It's 5,000 rupees for 15 days, right? So, how to solve the problems using your understanding of technology and engineering? We have to design that work. So we have to design our signal systems, whatever the things, whatever the problems we are defining, that can work. The process or device of understanding right gaps needs problem frame. We have to get into a reactive medicine. अब तक कैसी थी मेडिसिन? अब तक it was reactive. In the sense, हम कुछ करते थे, तो medicine will do it back. But now, what is intelligent? What is intelligent healthcare? What is intelligent? What is smart engineering? That is proactive, predictive, and preventive. Proactive means it will act, the devices will act before the disease will happen. In the case of insulin pump. When you talk about control systems, the control system between insulin pump and the CGM. The CGM will detect the glucose level, it will give that feedback to the insulin pump will inject the customized dose of insulin into the blood. Are you getting the point? अब तक क्या होता था? Insulin pump, it was just giving the static. Hypoglycemia हो जाता था. Hypoglycemia is also not good. Right? So this is how things are there. Okay? Then we have to go in the predictive. With AI we are doing a lot of predictions. And then preventive medicine. It closes the gap between diagnosis and treatment. अभी आज के टाइम में diagnosis और treatment के बीच में कितना टाइम लगता है? But when the smart healthcare will come, lot of gap will be covered. Right? So this is so जो भी तुम कर रहे हो, whatever like even at the very basic level, whatever signal processing you are doing, you should think that are we on these lines? Are we going on these lines or not? Right? Then when you talk about the intelligence of a device, it could design intelligence is one thing. Okay, so intelligence is not just technology or engineering intelligence. It is design intelligence, ability to translate complex algorithms into simple, ergonomic, and patient-friendly designs. Right? It is usability intelligence, intuitive human-machine interface. I think we have seen a lot of signal processing in these areas since last 2 days. Right? So on those lines. Empathy and by the way, anybody knows empathy? Empathy, Sunil? What is that? Yeah. So it is something to actually the whole point of design thinking is we empathize with our customers and try to understand their needs. That is the whole point of design thinking. We empathize with our customers. Okay. Why? Because we want to understand their need. Until you will go into a hospital and sit with a patient and understand that what pain he is going through, you won't be able to make a successful medical device. You will do something. Your device will work, but may not be usable. Your device will not get the market. Getting the point? So whatever kind of intelligent signal processing you are doing, first, before that, the first step before that is to understand the need properly. And then go with the intelligent signal processing. Right? Accessibility intelligence. What is that? Device works across socioeconomic literacy and disability levels. So as I told, CGM is CGM is like for 15 days it's 5,000 rupees. Every person can't afford that. Okay? So it's not accessible by many communities in the India. Fine. So whatever research, whatever projects, whatever inventions you are doing, do it rightly so that it should reach to the end user. Okay. Trust and explainability intelligence, ethical and privacy intelligence, ecosystem and interoperability intelligence. So when we talk about the intelligent healthcare, it's not just technologically intelligent AI. Technology is just one thing which will help us to make our device good. But to make that device reach to the people, it's these many intelligence we have to address. And whenever you are doing whenever you are working with any engineering concept, You should have these dimensions in the mind. Are you getting the point? Okay, good. So, as I told, technological smartness is just one dimension of an intelligent medical device. It is in smart healthcare, it is very small, so into that. So, good need identification, good value creation, and technologies. So, the combination of these two things will make your device good enough to reach to the. And now the question is how to find this intelligence within our system to solve identified problems. अब हमें ये समझ आ गया हमें करना क्या है, right? But how to do that? So we know now what to do, but how to do? You have the sheets of empathy map, need finding, and these exercises. We will do these exercises. So why? Traditional devices capture and display signals, right? तो अभी तुम जो भी लैब में तुम्हारे भी डिवाइसेस होंगे, हॉस्पिटल्स में भी जाते हो, most of them are traditional devices. Okay, and when we talk about the intelligent devices, they analyze the data, they predict, they adapt in real time using signal processing, AI, and control systems. Okay, so out of many devices that have been discussed till now, if you have seen that one device from Philips, where they have completely turned the ultrasound into a cloud-based system. So the most important part of the whole ultrasound machine is most unique part of the whole ultrasound machine is is the probe, transducer, probe, right? Because that is something which is emitting and receiving the waves. That's the most important point. So now what Philips has done, and so in earlier ultrasound machines, what was happening? It was bulky. All the system processors were inside the machine, which was when the cloud technology came, that was not required. So they have just put now they have given the connection of that probe to the mobile phone or any tab. You can directly transfer the data to the tab, to the cloud, processing is happening there. So they have made it so portable, so usable. You can take it anywhere, right? So this is how you should think when you are talking about engineering, solving engineering problems. You should think on those lines, right? Why needed? Because patients are living longer. So my point is why we are discussing why we are discussing about intelligent healthcare. Okay, why? What is the need? The thing is, patients are living longer with chronic diseases. Okay, the whole point is complexity is increasing. Right? Hospitals facing shortage of skilled staff. Data overload from multiple sensors requires automated interpretation. Precision and personalization demand adaptive learning systems. And human curiosity for working in extreme environments. If you heard about the Gaganyaan mission, okay, astronauts are going. We can't work with the sensors that we have on the Earth. Most of the sensors will not work because they have the gravity dependence. But there, the scenario is altogether different. It means there is no gravity. It's like microgravity kind of thing. Okay, so we need that kind of innovations in our signal processing. Microgravity, deep sea integrated medical device in our lifestyle. So here is just one of the examples of many smart devices that people are using. So it is like artificial pancreas that I wanted to show you, where the intelligent signal from the CGM, continuous glucose monitor, is going to the insulin pump. Insulin pump is giving the customized dose based on the input from the CGM. This is a whole control system. So you have to think on these lines when it comes to the smart healthcare. Okay. So what is the statistics? How this system has helped the people? We have numbers for that. People now have started. Now the people are getting 4 extra hours every day of stable sugar levels. What do you mean by this? Earlier, the insulin pump was just injecting some insulin, and maybe there could be a hypoglycemia. But there is a range of stable sugar levels, right? Around 100. So now, because of this whole control mechanism, the range is around 100, right? Not hyperglycemia, not hypoglycemia. So reduced hyperglycemia episodes by 30 to 40%. Okay, which could be hypoglycemia is equally dangerous. Right? I think it is more dangerous than Forecast fluctuations 30 to 60 minutes ahead. And this is all possible. From whatever you are doing, this is very much possible in the labs. It's just that we need to have that orientation. We are solving problems. Okay? It's just we need to take it to the innovation lab. Fine. So this is a very important part. Then another like smart ECG wearables. So if you have seen this device, which is just a credit card ECG detector, fine, by Alif Core. So this is another portable device that you can see, right? The same kind of signal processing is happening inside, but the usability of the device, the intelligence of the device has increased. What do you mean by intelligence of the device has increased in this point? Is because now the device is more usable, right? Device is doing more than the present devices itself. And that's what the topic of today's talk was. Intelligent healthcare, smart healthcare, right? And Apple Watch, I think everybody knows about that. Apple Watch is quite famous for all these news and all that. Okay, good. Intelligent ICU monitoring. This is another very big problem in hospitals. The point is the fake signals or fake alarms. Because we have thousands of devices in the hospital. Okay, and every medical device has some or other kind of alarm signals. Okay, and just to be very cautious, the manufacturers put lot of precautions because of lot of precautions. Unnecessarily, the manufacturer put lot of checks and balances, because of which the devices are giving fake signals, false alarms, which is the problem for the doctor, right? All the signal processing, control, everything is happening, but it's not proper. And what you can do in this, you can make an intelligent system and reduce the false alarms, and will solve a lot of problems with the hospitals. So these are some use cases of intelligent healthcare where we need more and more contribution, right? Okay, good. So it detects patient deterioration 6 to 12 hours before crisis. Some predictive algorithms. And it reduces the code blue events. Code blue events in ICU mortality by up to 25%. Reduce false alarms by around 80%. Right? So this is a very complex kind of intelligence. Tools are there, but we should also get into the mindset of solving problems. Right? If you are a PhD student, you can solve it more innovatively using your research. But if you are a UG student, then or an MTech student, then you have all the tools with you. Just you need that mindset, that problem to solve those kind of problems. Okay, the path to solve those kind of problems. Then smart processes. So the smart process is doing 10 different power movements, which is again useful for people. Okay, and this is as soft as like even it can hold the grape without crushing. Still, we don't have ICU monitoring extended into rural homes. We don't have a reliable patient monitoring system even today that we can take to our homes, right? Because our devices are not very intelligent as of today. And digital twins. That modern AI-driven hearing aids can process sound up to 50,000 times per second. This is one of the inventions that has been came to medical devices recently, and where the speech intelligibility is increased by 30 to 40% in noisy conditions. Right? Then, even compression algorithms are more or less related to signal and all that. Okay? So, people are coming up with like they are able to reduce the size of the signal to 100 of the original data size without losing critical signals. So the point is, you should use this kind of inventions, this kind of research into your problem solving, right? To solve the right problems which are actually the problem of solving. So a good intelligent device needs empathy, transparency, human-centered And as those devices are becoming more and more intelligent, these kind of questions are coming in again and again. Like, should I let ventilator override the doctor's command if it predicts harm? Okay. So if ventilator is intelligent enough, shall it override the command of the doctor to get switched off or not? Right? So these kind of things are there. Coming on to human-centered innovation. Why we need human-centered innovation? Can you just give a thought for maybe 15 seconds to let me know if you can understand about human-centered innovation? What common sense tells about the human-centered innovation? Okay, so these are again on the same lines that we have discussed till now. It's about asking the questions to the people. Okay, so yesterday that we had that statement that we don't have a good BP monitor machine in our house. Have you ever tried to understand that what are the problems with the present BP machine that we have in our house? Have you realized? Does anybody have BP machine in their house? Have you used that? So what problems you have found? Solution. Okay. What else? So have you ever thought to work on that problem? No. So I think when we come across any such problems, we should try. We should see. As an engineers, we can always do something. We should think of that how it can be made better. Until we think, even for next 100 years, we will be having the same BP machine in our house with same unreliability, right? So the whole point of empathy, human, and this human-centered innovation is to talk to people that what kind of devices they need. Okay. In this, we have to put different kind of intelligence in our device. That we have seen the whole list of different intelligences, other than the technology intelligence, right? So these are those somewhere between 70 to 80% of medtech innovation doesn't even reach to the market. Why? Because we don't identify the need properly. We just make something, right? Even if you are doing research, most of the time we do the research is just by reading papers. We get the problem out of reading papers. We should talk to people and then combine that knowledge with the scientific literature. That is the better way to get successful by the output of our research. Right? Okay, so this is the empathy. I think everybody has the copy. Okay. So now we will do a slide exercise for 5 to 10 minutes. Though it's a hour-long exercise, but we have to finish it within time. So what do you understand by this empathy map canvas? Everybody has. If they don't have, please sit with somebody who has. Can anybody give me the idea? What do you understand by empathy map canvas? So here we are trying to understand the problem from the customer point of view. Customer in the sense who will be using our medical device, the patient point of view. Okay? So what do they think and feel? If you will see here, it is about what do they think and feel. Think is, so let's say we'll just take this example of BP monitor itself. Okay, BP machine. What do they think? That is BP machine good enough to work or not? What they feel? Are they feeling are they irritated? Are they happy? Are they furious? What is the feeling of that person using that particular machine? So whatever projects, research you are doing as of now, you must be having some end product in your mind. And you must be working on solving some problem. and you will be coming up with some product out of that after solving that problem. Okay, are you getting the point? So, uh, then the point is, who are we empathizing with? Who are the people who we are empathizing? Why do they need to do? Why do they want to solve this problem? What do they hear? Let's say if you are saying it is working properly, are they hearing the same thing that it is working properly? If you are giving the right feedback, different. What do they say? What do they see? What do they do? So the point is, you have to understand your patient properly, their needs, their feeling, what they hear, what is in their mind, and based on that, you have to redesign your device to be more intelligent. A device is only intelligent if it can be used to its 100% capacity. Otherwise, the device is not intelligent. And I'm not just talking about the technical intelligence. Technical intelligence is one thing. So just I will give you the one example. So we were devising uh, that drip monitoring system with my students, and the student was very good in IoT coding and all that. So he has put all the IoT coding and everything in the drip monitoring system. Then we were solving that problem because hospitals aims they have those good machines, but the problem is with the PHC CHCs. I hope you know about PHC CHCs. Okay, there they don't have these drip monitoring systems. So when we have reached there, we came to know that they are not using smartphones, most of them. And if they are not using smartphones, how the IoT will work, right? So we had done all the good things. We have done put all the technology, but it was not used by the like end user wasn't able to use it. So that was the challenge there. So let's do this exercise for about empathy now. And let's say we are solving a problem of some person called as Ramesh, who's a 58-year-old. He has a history of hypertension, borderline diabetes, and risk of. So these are the conditions that he has. We have understood these conditions from him, right? So this is a approach. So this is, you can say, a framework to understand the need of the person for whom you are solving the problem, right? So whatever the projects, whatever research you are doing, whatever the end product you have in mind, also try to have the customers in your mind, okay? And talk to those customers. Make their persona, try to understand their condition, put the context, like living in suburban area, limited access to specialized cardiac care, and the goal. What is the goal of Ramesh? To stay healthy, avoid hospitalization, and peace of mind for family. This will give you the context in which you have to define your innovation, right? You can also reach rich or poor, whether he can afford the costly device. If yes, then the cost should not be a concern for you while innovation, right? So you have to do all these parameters. Then designing insight from empathy. Device must be non-intrusive, comfortable, easy to wear. So उससे बात करके हमें ऐसा पता लगा कि device should be non-intrusive, it should be non-invasive, it should be comfortable and easy to wear, right? Signal processing should filter noise and only flag meaningful anomalies, not false alarms, right? Most of them do not want that. Control solution should automatically adapt thresholds to the individual's baseline, not general population averages. So we want the more customized device, so that the device should respond to his thresholds, not the general study thresholds. Then only you will use your device. In the point? Right? Then comparing app should give simple, reassuring feedback instead of complex graphs. You need just very simple UI. Emergency alerts must directly notify family doctors and critical questions are crossed. So this is the whole context of your device, in which in this framework you have to make your device. You're getting the point? So your intelligent device should follow these things. Then only your device will become intelligent for Ramesh. Otherwise, that's just a simple device, because it's not performing these intelligent actions for Ramesh. Getting the point? So now, putting on the empathy map. So empathy map you have. Where is the point? What the user says. There must be a point where it is written what the user says, right? So let's redesign this empathy map for Ramesh himself. तो जब हमने यूजर रमेश से पूछा तो रमेश ने क्या कहा? I don't want to visit hospitals all the time. So these are very important questions, and you should have the answers for it if you really want to make an intelligent device. Right? Again, I'm saying, I'm repeating. I just need something simple to use, not complicated gadgets. Ramesh doesn't need complicated gadgets. Okay. There is a part in the canvas where it is written what the user says. Can you find that? It is there, right? Then I worry when I feel chest discomfort, but I don't know if it's serious. So this is what he is saying. Okay. What he is doing? What Ramesh is doing? On the right hand side now. Frequently check blood pressure manually. He frequently checks the blood pressure manually. Avoid long travel due to health concerns. And rely on his son daughter for scheduling doctor visits. Right? So the whole point is we are trying to make an intelligent device for Ramesh, for which we have to work with our own signal and control systems, intelligent signal and control systems, so that we can come up with a smart. Okay. What the user thinks, what the Ramesh is thinking. What if I collapse when I am alone? So you have to address this problem of him when you are designing this device. Doctors don't always have time to listen carefully. This kind of intelligence should be there in your device. Then only you will use that. Okay. And technology can help, but I think it may be too technical or unreliable. He wants a simple device, not too technical. Okay, not too complex. What he's feeling, he's anxious about certain health risks. You have to address this feeling of Ramesh, right? Embrace about being dependent on family. He don't want to depend on the family. Relief when symptoms are monitored and explained clearly. He wants the explanation of everything that has happened with him. He wants the complete peace of mind, right? So I've shared this empathy map with you to understand the whole point of the need for the Ramesh if you want to make a device for people like him. And if you will take this interview with 100 to 200 people, then only you will understand that what could be the good features for your device that should be used by the end user. Okay. So intelligent signal processing role, what is the noise removal from ECG signals? Motion artifact that we have seen. Motion artifact is one of the biggest villain when it comes to medical devices, wearables, for adaptive thresholding for detecting arrhythmias. Okay, I think you all know algorithms about adaptive thresholding. You all know algorithms about noise removals. I'm not getting into those algorithms because they are well structured in the literature. A lot of science has been done. You can always go and see that. But I am more focusing on the problems that can be solved using your knowledge. Predictive modeling of forecasts, earning modeling systems, and personalized baseline for each patient reducing false positives. So these are few good characteristics that your device should have to be called as intelligent. Okay. Then what is the outcome? So now Ramesh is using your device, your device. The outcomes are good. Ramesh is feeling safe, more independent. Family gains peace of mind. Doctors receive actionable pre-processed data instead of the raw overload, and the healthcare system reduces unnecessary hospital visits. Good. So whatever projects, whatever research you are doing, align your mindset into this kind of framework. Okay, it will be helpful. So when we talk about the intelligent healthcare intelligent algorithms, we just would like to have a look on the kind of algorithms that has evolved over time. Right? So the earlier algorithms were not very intelligent. And what was there? ECG signal processing and AF detection. That algorithm came in 1985 and Tompkins algorithm. I think most of you who are working in ECG, you know this. Tompkins book is also there. Okay, very famous book. Then in 1990s, these hidden marker models in medical speech and genomics has come. So you can see the evolution of the algorithms, evolution of the intelligent algorithms over the time. Okay, and you will get the good idea of that how we are today and what is the power of today's algorithms, and that's why we need these kind of talks as of today. In around 95 to 2005, there was support vector machines for cancer detection. Then in 2012, around the CNNs in medical imaging came. In 2017, around transform models have came. Then 18, reinforcement learning. And now the people are mostly working with model predictive control and graph neural networks. Right? So this is how the complexity of the algorithms has increased over time. From the very simple algorithms to the more complex algorithms, which handle real-time data, multivariate signals, and all other features. So this is something the one comparison chart I have made for algorithms from the older generation to today to the future ones, and what are the different characteristics which define these algorithms. Okay? So the point is, the old algorithms are handcrafted, written, reactive, single task. Those algorithms of maybe signal processing or you can say control systems, anything, they are single task algorithms. They are not able to handle complex data. Okay, they are reactive, means you will give some input, then they will give out. Brittle, they were not robust, then handcrafted, very specific to that particular need. Then the new class of algorithms that we have today that are adaptive. Okay? Adaptive in real time. They are predictive. They are generalizable. They are multitask. They have the sense of privacy. Right? So this is the definition of smart algorithms that we have. And whatever algorithms we have seen since yesterday, they have these kind of features. Right? So whatever things you're working on, that should. So when we talk about the data integration as one of the characteristics, the old generations were single modality, the new ones are multimodal, and the future ones will be including variables, genomics, and social determinants. When we talk about adaptivity, the older generation were fixed thresholds. Okay, means let's say if you have designed something to just work for 40 degrees, that device will only work for 40 degrees Celsius. But now the algorithms are predictive, adaptive, and personalized. And the future ones will be continuous online learning, multiplication, transfer learning. Well, they will learn themselves. This is how the machine learning and all that kind of stuff is working on. So, as of now, we are here. Most of the things we have achieved this. But the point of this slide is to give you the idea that from where we are coming. Right? When it comes to prediction, earlier it was immediate and reactive algorithms. Now we have predictive, future will be long term. Decision support. Earlier we had just alerts and warnings. It was just alerts and warnings. Now they are prescriptive, proactive, future will be alarms. Then robustness, earlier was sensitive, now the algorithms are more robust. So coming on to multimodal, so these are just some use cases which are there because of multimodal data fusion. And with the help of that, the code blueprints have been received
Banners.
in the IC model. And when it comes to adaptive and real-time control, the numbers have the range that we discussed. That the person is getting now 4 hours more into the safe range of glucose levels. Okay, so we can have a look at that need finding. I have tried it. That is good. So just if you can go through this need finding worksheet. I think everybody has this need finding worksheet. Right. So here we are trying to understand the actual need that I think you just go through it and normally we do the teams. Normally how we do this exercise is we make a team of 3 to 4 people. They discuss and then we come up with the solutions. But as of today, the strength is also not good. And so we will just try to do on the individual level. Okay. So whatever the problem you have in your mind as of now related to healthcare, try to see that where is the observation is happening. Okay. So let's say if we will take just an example of this BP machine, where is the observation is happening? In houses. It's a home way. Okay. And who are the main people involved? Maybe the patients who are BP, patients, or maybe the normal patients, right? But more critically the BP patients. Stakeholders, primary users, affected individuals. Who are primary users of this? What are secondary users? Who are secondary users of the BP machine? The family members who will be taking the BP. Fine. Then the decision maker. So who is bringing the BP machine into the home? So the whole point converges to that you should identify. So your machine should be intelligent for the secondary user also. Your machine should be intelligent for the first user, that is there, whoever is using. That should be comfortable, but it should also be useful for the secondary user. So then observation notes, pain points, unmet needs. Right? So this is something that we can see more in detail. So the whole pipeline goes like this. We have the signal, we do the processing, we get features, we do some kind of control over that, and some action to discuss our important HTML. So you can think, so like when it comes to understanding this kind of need finding, you can think of these things like what healthcare tasks are inefficient. So if I will say you that what healthcare tasks are inefficient, where is technology failing the patient? Is any particular answer is coming to your mind to these questions? So if somebody can come up, where is technology failing the patient? Anybody would like to answer? Sorry? Complex UI. Okay. So now we have to get into more detail that what kind of device you are talking about. The used in hospitals or that is used for home or like with some care hospitals. Great. So this is a good need identified that even in the hospitals the machines are not having very easy to use GUI. So that is something problem that you can solve. Okay, so definitely that is not a mostly technology problem. Maybe it's a design problem, but you can always think of a technology problem also on those lines. Fine. So like, what is technology? Where is technology failing the patient? You can say that uh, even in multimodality imaging, right? Means most of the research is happening in those areas. What healthcare tasks are inefficient? Can you think on the lines of signaling systems or control systems? So any medical device that you have used till now, maybe wearable or anything, where you think the healthcare tasks are inefficient on the lines of signal processing or okay. So we need more time for these kind of exercises. So the whole point here is to put a seed in your mind that okay, you can start thinking on these levels. If I get the chance to come up again, then we can discuss more about these things. So one problem you can think of is like this one, that the lack of affordable continuous glucose monitoring in rural areas led to low cost wearable glucose sensors. Right? As I told, the CGMs are very costly, 5,000 rupees for 15 days. So obviously that's not affordable in the low resource settings. Fine. So this is the whole process of product development. Just to give you the context, and we are at this part: need finding and need scale. Then we have concept generation, and there we use the actual technology, actual signals, and actual controls and all that. So as I was discussing about tame problems and the wicked problems in the starting. So tame problems are something which are very algorithm oriented. The normally we do in the engineering. Okay. What are the wicked problems that are ill structured, uncertain, no clear scope and role, involve human, ethical, and contextual complexity. So just to give you a more idea about the tame and wicked. So noise reduction in biomedical signals is a tame problem. We have defined algorithms. Everybody agrees? We have defined algorithms. Everything is mathematical. We can do it. Closed loop glucose control. That is also a tame problem. Algorithm based. PCG detection. It's a tame problem. Now what comes the wicked ones? Alarm fatigue in ICU. Okay. Personalized treatment control, because people whom you are giving the personal treatment, okay, as a doctor, they have emotions, they have complexities. If you will solve one problem, maybe they can say maybe you can say that you are taking their MRI, but he or she may feel uncomfortable in the gantry. That is again a problem, right? They are not comfortable in that gantry. Sorry, claustrophobia. Then integration of multimodal data. That again is a wicked problem. Okay. So as in the last lecture we have seen, because of uneasiness of the patient, maybe you are not getting the right signals, right? So what is happening? You are solving that in the from the wicked point of mindset. Okay. You have to solve those problems as the wicked problem. Ethical and legal control decisions. So this is how the 10 problems work. Problem to the solution. You have one problem, solve that, you will reach to the solution. And what about the wicked problem? You have a problem, you are giving a solution. It is creating more problems, right? And we have to get the more solutions, then this thing will go iteratively. Fine. So we have something called as problem framing canvas. I think everybody has this one, this third sheet. Okay. So uh, so now we have done the need finding. Okay. So what are intelligent devices which are uh, addressing all the kind of intelligence that we have? We have seen design intelligence, okay, ethical intelligence, empathy intelligence, and technological intelligence is always there. So now we are trying to frame the problem, okay, a problem that is worth solving, and after that only we will come to the solution. So context. When does the problem occur? So the point is context is very important. It will give you the understanding of the background of the problem. Right? We have seen in the case of the Ramesh, his demography, his likes, his dislikes, his emotions, okay, his family dependence, everything. It helps you understand that. Then what is the root cause of the problem? So if anybody can say what is the root cause of that problem, the problem that we defined in the case of Ramesh. So the root cause of the problem was his insecurity of the dependence on his family. How you can address that? How you can address that technologically? Right, by solving it as a wicked problem and to use the algorithms like intelligent signal processing control system algorithms which can reduce his dependence on his family members. Then only you can make an intelligent healthcare device for him which he will be using. Otherwise, your device won't be useful. Right? Okay. Alternatives, what do customers do now to fix the problem? As of now, how he was fixing the problem? By visiting himself or calling the doctors. Okay. So again, there we need the technological intervention using smart algorithms, smart healthcare, intelligent algorithms. Customers, so this we have identified. Emotional impact. What is his emotional impact? He will be more independent, find more confident about his own lifestyle. Quantifiable impact. So this is something like number kind of thing. You can say he can save his. Let's say if you are making a device for him which can reduce his hospital visits, right? Maybe by 10%, 20%. So that kind of number we will try to put here. Quantifiable impact. So let's say if every week he is going to hospital, then you can say that we are reducing his hospital visits by 20% in a month. So this is something which will put you in the right context of solving the problems. And I think that is enough for today. Okay, now we can come to the questions. No questions, I think. ठीक है, thank you.
Thank you, sir, for such a visionary and insightful session. We now request Dr. Vivek Kumar, sir, to kindly felicitate Dr. Saurabh Gupta, sir, as a token of appreciation.
With that, we officially conclude day 2 of the ANRF workshop. We sincerely thank all our speakers, participants, and organizers for making today a success.
We look, we look forward to seeing you tomorrow for another day of learning and innovation. Thank you and have a wonderful evening.
Thank you. It is to inform everyone that tomorrow the lectures will be conducted in CLA 2. In the CSE department, CLA 2. All the lectures tomorrow. Thank you, everyone. Okay. All the lectures tomorrow will be conducted Computer Department CL2. Thank you, everyone.